Hey, I hope everyone's having a wonderful day. I'm shooting this on Christmas Eve. Just got back from the gym and decided to tackle. This is the two remote control units that are going to go in the Commlock. This is the transmitter and the receiver, which I'll make a little box which will have tabs that I can hook it up to, like light bulbs or whatever, because I'm not going to be doing door openers and stuff like that. At least ways not yet, but the receiver board will have maybe a couple of mechanical relays on here. I emphasize that because I am using a solid state relay in this project. These are, and that's why I kind of decided I'd shoot this video a little early before I got it actually into the prop, and while it was still out here in the prototype proof concept stage. I had a problem when I first put this together. These are built around the PT 2264 and 2272 M4, which stands for momentary. Make sure that's correct. 2272-M4. And these little 433 megahertz transmitter modules and receiver boards. I bought these. I bought a bunch of these back. Geez, the dates on some of them are like '08. These didn't have any. Oh, maybe it does. The other ones I used didn't have dates on it. No, unless no, too many numbers for it to be a date code. So no date on these. But this is a standalone 433 megahertz transmitter with a data input and provisions for an external antenna. There's a small board mount antenna, but I've added a true antenna for both the transmit and receive boards, so you'd have acceptable range. I mean, so that I would have acceptable range. I gotta stop making this sound like I'm building these for sale. I'm not. Anyways, so again, one reason why I decided to start the video at this point was I had a bit of an issue with these, well, with the whole setup. When I had the original configuration where power was going to the transmitter all the time, my receive LED was illuminated all the time, and that was good because that told me that this board was talking to this board, and that the code that I had selected, which these have 8 pins that you tie either high, low, or neutral for a exclusive code between the two boards so that they don't step on each other. And what I was noticing was that no matter what I did with the keypad, the channel would go high and then stay there and only reset to 0 when I cycled power. And I'm thinking, wait a minute, that's wrong, because I intentionally ordered momentary and not latching. Did I get a bunch of counterfeit parts that were actually latching and not what I thought they were? Well, I kind of did some troubleshooting, and again, the data sheets that you get with these things are horrid. They're, I don't know. I'm used to large company data sheets that really give in-depth data, sometimes for like Intel and Atmel and some of the other big name chip manufacturers. The data sheets can have as much as 200 plus pages. The data sheets on these, I think this one here, let me see, is well, it's got 18 pages, but a lot of it is kind of like garbage. Information that really is even vague at best. And so what they didn't tell you was that you need to cycle the power on the remote, and that didn't make any sense until I realized these things are usually set up for, oh gosh, I thought I had one here, for little keychain remotes. And how those remotes work is, well, here, let me pause this and I'll go get one. Hold on. Okay, I'm back, and this is the little transmitter that I was talking about, where you only have power coming out when you push the button. As a matter of fact, the whole unit is de-energized when it's sitting like this, and only when you push the button do you get power here, and you'll see here power there. Now, and so when you push the appropriate channel, you'll see the scope responds accordingly. It's momentary, so the output only remains high as long as the button's pushed. But it kind of eluded me at first, and then it dawned on me, oh, you knucklehead, you can't have this thing energized continuously. You have to do exactly what this configuration, which utilizes the same transmitter in a cap or in a module configuration, whatever you want to call that. Here, as in here, just a much bigger board, and definitely wouldn't fit into the Commlock. So that's why I had to basically make one from scratch, and also made it a little bit better, adding smoothing and decoupling capacitors, a proper antenna, but not mimicking what's going on here. So that's when I decided this morning, with my little prototype setup or proof of concept setup, I made a push button array here, and what I did was all the switches are common on one side, and I had it being pulled high or tied high, and the switch pulls each line to ground, as you would see in the datasheet. And I decided to take advantage of that and bring in a solid-state relay that the LED side was on the switch circuit, so that when I pushed the button, which I think it's this one here, yeah, there we go, you'll see here, I'll push this button here, you'll see that go on, there you go, and the output switch. That's because the power's off. I use a solid-state relay to actually control the current to the transmitter. So what I thought was going to be a long, drawn-out, laborious redo of the circuit turned out to be a very easy, quick fix utilizing these 61G1 solid-state relays by Omron. I bought a boatload of these. They're obsolete now, but work perfect for me. They're good for 60 volts, and they'll switch up to 400 mils. And the nice thing about them is the way the output is configured. It's FET, so they're tied in series, so that you get the ability to run them with an AC circuit or a DC circuit. And the added perk is, in the DC circuit, polarity is not critical. So they're really nice components, and have come in handy for a lot of different applications. They're not fast switching, so if you're doing high-speed switching, I don't recommend them for that. I'm not sure what their switching speed is. Let's see if I can scroll through the data sheet here. Typically, it's 2 milliseconds for an on, and you have the typical rise of about a half a millisecond. So they are relatively slow, but for this, doesn't bother me in the least. And what's really good is I've already got the switches installed in the prop, or in both props, so to add this circuit, all I got to do is, on the back side, go in, and I should be able to do it relatively simply, and I'll pick this video up once I have that done. But this is just so happy that I was able to have this. You can see the slow response time here. It takes actually a second for this. I don't know if it's the cap on the board that's causing it to hang slightly, but I don't care for what I'm doing. Not a big deal, because again, it's just being able to say, well, my Commlock has got remote control. I can open and close a door. I can turn on and off a light, and I can do it on 4 separate channels. So again, I'll pick this video up once it's inside the Commlocks, and I can demonstrate it in that capacity. So stay tuned. I'll post this video. It'll probably be after Christmas. Everything's really hectic around here, so yeah, I'm probably not going to have a chance to get back on this until after the holidays. So I'll post this video now, and the rest of it will come online maybe the 26th or the 27th. So have a great, have a very Merry Christmas, Kwanzaa, whatever you happen to celebrate, and I'll see you later. Bye.